Okay, in our previous video, we have studied about the Newton's first law, second law, as well as the third law of motion. In first law, you have already studied that if a body is in rest, it remains at rest, and if it is in motion, it definitely remains in motion because if external force is not applied, then it will be remaining in its own state. Okay. Now, in second law, you have studied about the acceleration of the body, and it depends upon the force. It is directly proportional to force, but it is inversely proportional to the mass. If the mass is heavy, then extra force must be needed to apply. Okay, force will be more force will be required if we want to move the body for a larger distance, to cover a large distance. Okay, in third law you have studied about the body. If we apply the force on that particular body, that body will also apply a force in the opposite direction, but the equal force. Okay, to every action there must be an equal but opposite reaction. Okay, reaction will be there, but it will be in opposite direction. Okay, it is the third law of motion, Newton's third law of motion. So today we are going to discuss about some concepts about the second law. First law is also contained in second law. You must now hear that first law is also contained in second law, third law is also contained in second law. That means in second law contains both first law as well as third law. Second law, Newton's second law of motion, contains first law as well as third law. I will derive the Newton's first law from second law. Also at last I will derive Newton's third law from second law. This is all about today's lecture. Okay, I will be discussing these things in today's lecture. So starting with the Newton's first law is contained in second law. Now Newton's third law is also contained in second law. It is after some time I will teach you after taking the concept, after giving you the concept, after clearing the concept about the Newton's second law, how Newton's first law is contained in the second law. I will derive the Newton's first law from second law, then you will come to know that this was contained in actually second law of motion. Okay. So firstly, I have written that according to Newton's second law, F is equal to ma. You have already studied in previous lecture that F is equal to ma. Here we can say that acceleration is directly proportional to force, but inversely proportional to mass. Acceleration is directly proportional to force, but inversely proportional to mass. If you want to accelerate the body for a long distance, then you have to move that body. You have to apply the more force, that is more force is needed to move the body for a larger distance. But what about the acceleration if the body has some mass? Okay, if the mass varies, then of course it will depend upon the acceleration of the body. If we want to accelerate the body for a larger distance, then its mass must be lesser. Okay, it means it is inversely proportional to the mass but directly proportional to the force. Okay, I have written here F is equal to ma. What about the force if the applied force is 0? Okay, if there is no external force acting on any body, then definitely that force will be equal to 0. If F is equal to 0, you can say that ma is equal to 0 because F is equal to ma. Okay, F is equal to 0, then ma is also equal to 0. If ma is equal to, if there is a massive body, then it must have some mass. Its mass can't be 0. So if m is not equal, definitely a will be equal to 0. Na? A will be equal to 0 because there is the product of the two numbers, that is the two terms m and a. If m is not equal to 0, then a need to be 0. Okay, a must be 0 because if the product of the two things is 0, two numbers is 0, two terms is 0, then one of them must be 0. You know, if we have a number 2 and some other number and result is 0, definitely the second number will be 0. Okay, the result can be nothing except 0. If you write here any other thing, then it will not become 0 equal to 0. So to become 0 at the right hand side as a result 0, you have to put here only 0 and nothing else. That means you can write also like this, 0 into 2 is equal to 0. That means from the 2, 1 must be equal to 0. So m is not equal to 0, a must be equal to 0. A is what? A is the acceleration of the body, and acceleration is the derivative of velocity. And if acceleration, that is the derivative of the velocity, is 0, then velocity must be constant. Why? I have already told you in the first chapter where we have studied about the differentiation and integration. I have already told you that if the derivative of a function is 0, if the derivative of a function is 0, then that particular function must be constant or 0. Okay, if the function is constant, its derivative is 0. If the function is constant, its derivative is 0. Okay, now acceleration is the derivative of velocity. So if acceleration is 0, definitely the velocity will be equal to constant. or it may be 0 because 0 is also constant now. So velocity is constant or maybe 0. Okay, so dv by dt is equal to 0. Dv by dt is equal to 0. That means a is equal to 0. A was equal to 0. So dv by dt is equal to 0. If dv by dt is equal to 0, it's a velocity derivative is equal to 0. If derivative of the velocity is 0, velocity will be constant, and velocity is equal to constant. What does it mean? That means if the body is moving with a constant velocity, then its acceleration will be equal to 0, and if no force is applying on the body will remain in its state. If no force is applied on the body will remain in its own state. If it is in rest, it will definitely remain in rest. If it is in motion, it will remain in continuous motion until or unless an external force is applied, because force applied is 0, so body will remain in its own state. Okay, if it's rest, then it will remain at rest, that is acceleration is equal to 0. Acceleration will be something. Okay, when we can at that time we will say that the force is applied, and if body is moving with a constant velocity, no force is applied, then it is also possible na? It's also possible it will remain in its own motion until or unless external force is applied. Okay, which was the first law of motion. That means I have derived first law of motion from second law of motion. What does it mean? It means first law was contained by second law. Okay, I have derived it from the second law. Now, what about the third law contained in second law? It means second law also contains third law. Na? I will derive the third law as I have derived Newton's first law from the second law. I will also derive Newton's third law from the second law. Second law contains both the laws in it, and I will derive from the second law Newton's third law. Okay, how? To every action there is equal and opposite reaction. How will I derive it from this? Look here, F is equal to dp by dt. How? Because the rate of change of momentum is the force. It is the Newton's second law. The second definition I have told you about the Newton's second law in previous lecture, that dp by dt is equal to F, or F is equal to dp by dt. That means force is the rate of change of momentum. Okay, in dp by dt. FAB, what is FAB? FAB is the force applied by the body B to body A, and FBA means force applied by the body A to the body B. Okay, now F is equal to dp by dt. dp by dt, if applied on A, it is A. If applied on B, it is B. Okay, now total, how much force will be applied? Total force will be F is equal to FAB plus FBA. You can add up these forces. FAB plus FBA means FAB's value is this and value of FBA is this. Okay, like this you can write, it is a vector quantity. Okay, now force is this. What if force applied is 0? If no force is applied, no external force is applied on the body, then we can say F is equal to 0. F is equal to 0 because force is not applied here. Force applied is 0. Then if F is equal to 0, definitely this whole thing will be equal to 0. This whole thing is equal to 0. That means FAB plus FBA is equal to 0. If FAB FBA is equal to 0, then it will change its sign. That it is plus here, it will go in the right hand side and change its sign plus to minus. Okay, in the right hand side. Now FAB is equal to FBA. What does it mean? It means the forces are equal and opposite, which is the Newton's third law. Two forces are equal and opposite. If there is an action, there will be a reaction. That is, two forces are equal and opposite to each other. That was the third law of motion, Newton's third law of motion. Okay. Now what I have done here, what I did here, I firstly took the second law. In both the cases, I have took second law. Okay. So from second law, I derived the first law, and from this particular second law, I have also derived the third law. That means second law was that law which contained both first as well as third law.